Okay. Now, whenever you mix together a strong acid and a strong base, what will the two do to each other? They will neutralize. So a strong acid, what am I doing? Oh, there we go. Favorite pen 1, favorite pen 2. When you mix together a strong acid and a strong base, the two will neutralize each other. Now, when they neutralize each other, we have an acid plus a base gives a salt plus water. Now, it used to be in the past, it's too warm today. It used to be in the past that we would just be like, okay, we're done. But we have recently learned something about salts. What have we recently learned about salts? Some ions hydrolyze. Some ions in the salt hydrolyze. Not all the time, but some of the time. So we don't just get to say, oh, neutralization, and then it's pH 7. Because what can happen is you can have that neutralization and you can produce a salt which will go on to hydrolyze. And if you remember the definition of hydrolysis, it is the reaction of an ion with water to produce an acidic or basic solution. So the salt, after it's turned to pH 7, the salt can go on to make the solution either higher than pH 7 or lower than pH 7. Now, in this particular case, what do you know about Na+? Does Na+ hydrolyze?
No.
What are the 4 positive ions that hydrolyze? There's only 4.
Ammonia.
4 positive ions. The only 4 positive ions that hydrolyze are ammonium, not ammonia, just ammonium, because ammonia is a compound into and of itself. It's a molecular compound. It's not part of salt. Okay? Iron. Aluminum.
And
Chromium. Feel creepy. Yes? All right. So those are the only 4 ions that hydrolyze. So will the sodium ion hydrolyze? No. Now we need to look at the other ion, which is the chloride ion. Okay, so you have to look at both the positive ion and the negative ion. Does the chloride ion hydrolyze? So if you have an anion, look at the conjugate acid. If it's strong, do you get hydrolysis?
no.
No hydrolysis. If weak, yes, hydrolysis. So, who is the conjugate acid of chloride? Conjugate acid is HCl, and HCl is strong. So is there any hydrolysis? No. So Na does not hydrolyze. Cl does not hydrolyze. And so therefore, the salt we have produced is what kind of salt? Acidic, basic, or neutral? It is a neutral salt. So the salt produced does not hydrolyze. Now, this is actually very important. If the moles of acid equal the moles of base, and we don't have any excess of either, the solution will be neutral. And today, we're mostly going to be looking at salts. In fact, we're only going to be looking at strong acid reaction with strong base. So the conjugate base or the conjugate acid will always be strong in this case for your ion. Later on, we'll look and we'll say, what happens if we get a salt that is not neutral? What if we have an acidic salt? What if we have a basic salt? But that's not what we're looking at today. Today, what we're going to look at is we will have a salt that does not hydrolyze. And so if we have a strong acid and a strong base, neither ion will hydrolyze. And so now it just depends. So the salt won't affect the pH. So the only thing that's going to affect the pH is the quantity of acid you added and the quantity of base that you added. SA stands for strong acid, SB stands for strong base, if you hadn't caught that yet, okay? So, if neither the acid nor the base are in excess, then the pH is going to be 7 because all you've got is the salt. Does that make sense? But what if you added more acid than you added of the base? You would have salt plus water plus leftover acid. So the solution would be acidic and the pH would be less than 7. If you have excess base, you would have the salt and the water and you would have leftover base. So the solution will be basic and the pH will be greater than 7. So let's take a look at this first example just to get an idea of what the math is going to look like, and then we'll work through some more complicated examples. What is the resulting pH when we mix 10 milliliters of 0.1 molar HCl with 10 milliliters of 0.1 molar NaOH? Now you'll notice we have the same volume and the same concentration and the same concentration. What does that tell you about the number of moles? Yeah, because volume times concentration equals moles. Yes? Okay. Volume times concentration equals same moles. Volume times concentration equals same moles. And if you have the same moles of acid and base, what do you know about the solution? It's pH once those two are mixed. What's the pH going to be? pH is going to be 7 because the only thing you have left is the salt. Now, let's just go ahead and prove this because this is the math we're going to use for more complicated examples. Okay, so we can say, and we're actually going to use the net ionic equation because in the examples we'll do next day, not tomorrow, but the day after, we're going to have a non-1-to-1 ratio. Okay, and it becomes really easy then to work in terms of moles of H and moles of OH. Okay, so our moles of HCl, we take our volume of the HCl and we multiply it by the concentration of the HCl, and then we multiply it by the mole ratio, and we get 0.0010 moles of H+. Is that easy enough math?
Yes.
Okay. Moles of NaOH. You take your volume. Moles of OH, you take your volume of the NaOH, you multiply it by the concentration of the NaOH, you multiply it by the mole ratio to get OH by itself, and we get 0.001 moles of OH minus. And these two are the same. 0.001, 0.001. Okay? But like I said, we're going to prove this. We're going to go through all the math, and then we're going to do it for a situation where it's more complicated. Okay? We are going to use the net ionic equation for the reaction of H plus and OH minus, which is going to be the same no matter what strong acid, strong base combination we use. Yes? So let's take a look at this. Because the reaction between a strong acid and a strong base goes to completion, so when you have strong and strong, it goes to completion. In fact, even if only one of those two is strong, it will drag that reaction to completion. Okay? We can use a Rikva table, which I have yet to find a better name. It's kind of like rice, but R stands for reaction, I stands for initial. C stands for change in. And instead of E for equilibrium, because this is a completion, we're not going to equilibrium, we are going to our final. Okay? And in this table, we are not using concentrations, we are using moles. So here we have our initial moles of H+, we calculated that. We have 0.0010 moles of H+. And we calculated the moles of OH minus, 0.0010 moles. Now, how much is going to get used up? All of it, because they have the same amount, right? So we have all of it being used up. So how much is left? 0. Okay, so this is going away. And what are we making? We're making water, and because this is not concentration, this is in moles. We can have moles of water, yes? So the moles of water is going up. Okay, and at the end, we can say we have no 0 molar H+, we have 0 molar OH minus, and we have 0 moles of hydrogen, 0 moles of OH minus, and 0.0010 moles of H2O. Is good? And so we have just proved there's no hydrogen, there's no hydroxide, so the solution is neutral, pH equals 7. You would not have to show this amount of work. You could just be like, oh, you could calculate out the moles, and you could be like, oh, they're the same, so it's neutral. Okay? But the fact that you now know what a Rikva table is, that's going to be useful for our next example. Example 3. Now you can choose to follow along with the thing in the book, or you can choose to grab a piece of paper and work along with me, because I'm going to do it off on the side here. And this is page like what, 105? Something like that? No. No, it's not. What page are we on? 60. Excellent. Not 105 at all. All right. Now, some of you are going to hate me, but I'm going to introduce you to millimoles because at university they love using millimoles. They're easy. All it is a thousandth of a mole. Yes? What's the abbreviation for millimole? It is mmole. Okay? And you will come to appreciate it because it's got so much less zeros involved. And it's like you don't have to write as many zeros. Okay. So what we have here is we have 10 milliliters of 0.1 molar HCl. And we have 90 milliliters of 0.1 molar NaOH. Now, if you remember what we did on the previous page, we found the moles of H and we found the moles of OH, okay? This time we're going to find the millimoles of H. And that's going to be equal to the millimoles of where is the H coming from? HCl. Okay, now do you guys remember what the word of means? Of means multiply, times. Of means times. So all you have to do here is you have to say 10 milliliters, and instead of the word of, you just write everybody times. And then we say 0.100. And I'm going to write this as moles over liters so you can see the cancellation. Now, what am I left with here in terms of units? I've got mole here, and I have milli here. Is good? Okay. Now, what's 0.1 times 10? 1. So guess what? I have 1.00 millimoles of H plus. Oh, isn't that a nice number? 1. Isn't that better than 0.001? It's tidy. And if you really hate millimoles, you could do this whole thing just in liters, okay? What's the second thing we find when we're mixing a strong acid and a strong base? Find millimoles of OH. Millimoles of OH minus. And that's the same as the millimoles of NaOH. And we have 90 milliliters of 0.100 moles per liter. And the liters cancel, and we are left with millimoles. So now our number 0.1 times 90 is 9. So we have 9.00 millimoles of OH minus. So step 1, find millimoles of H. Step 2, find millimoles of OH. What is step 3? Draw a RICFA table. Okay. And remember, this is moles now. Okay, so I'm going to put RIC moles and F moles. And what are we going to use for the reaction? We're going to use the
Net ionic equation of water.
net ionic H plus plus OH minus. So we're going to have H plus, we have OH minus, and we are making water. Okay? Initially, how much H plus do we have?
1 millimole.
1 millimole. And in fact, I'm just going to put a little m over here. 1 millimole, millimole, millimole. Okay? So I have 1 millimole. How much OH minus do I have? 9 millimoles. And the nice thing about this net ionic equation that is always going to be 1 to 1. Yes, there's always going to be 1 H for every 1 OH, which means that you can determine who is the limiting reactant and who is the excess reactant. Who is the excess reactant here? OH minus. Who is the limiting reactant?
H plus.
H plus. So how much is the change going to be?
8 millimole.
Is that the change?
1 millimole.
1 millimole. Okay, so I determine who is the smallest. Okay, and so we're going to subtract the smallest. And so we end up with 0 of our limiting reactant. And we end up with 8 of our other reactant. And I suppose we could do water, although it really doesn't actually even matter, right? It starts at 0, although there's 1,000 moles around already, like 1,000 million moles. You know what I mean? Because it's the sol. Why is there so much water around? Why is there so much water around? So it seems weird to be putting 0. What kind of system is this? Is it solid, liquid, gas, or aqueous? What state is the H plus? It's just like your titration, everything's aqueous, okay? Everything acid base is all in solution, okay? So this is aqueous, the water, of course, is liquid. I mean, we don't really have to write down water, but we could say, okay, it starts at 0, it goes up by 1, and you end up with 1 extra mole. Why am I saying 1 extra mole? Because there are so many waters anyway, because water is the solvent. Yes. Okay. Yes. Yes, water is the solvent. Okay, so here's OH, and that is our excess reactant. And how much is it in excess by?
8 millimoles.
8 millimoles. Okay. And so now what we do is we say step 4, we want the pH, yes?
Yeah.
Now, if we know that there are 8 millimoles, and this is millimoles of OH minus, what would we want to find pH?
POA.
We would want to find POH and work our way to that. And if we want to find POH, what do we need?
Molar.
We need concentration of OH. Can we find the concentration of OH minus?
Yeah.
Concentration of OH minus equals millimoles of OH minus over milliliters of solution. Yes? So we know we have 8.00 millimoles of OH minus. How many milliliters do we have?
We have 20 milliliters,
We have 20 milliliters?
10 milliliters of oh no, we have 100 milliliters.
Ah, yes. So you have to go back here and you say, oh, I've got 10 milliliters plus 90 milliliters is equal to 100 milliliters. Okay, so this needs to be your milliliters of solution is the total volume. Okay, so that is going to be 100 milliliters, which is 10 milliliters plus 90 milliliters. How many sig figs in that 100 milliliters?
There are 4 sig figs.
4 sig figs, because remember we go to our first uncertain digit, which is the 0.1 position. Okay, we do that and we get 8 divided by 100. 0.0800 molar. Yes? And then we can say, okay, what's my POH? Equals the negative log of 0.0. This part is just like, you know, molar log 1.0969, and then pH is equal to 14. How many sig figs do we want? We want 3 sig figs. So 14 point, how many zeros should I put?
3 0.
1, 2, 3 minus 1.0969 equals 12.903 is our pH.
Oh, so what it says on the textbook is wrong?
Oh, did I? Well, let's check. Let's check and see if I did anything wrong. 8 divided by 100 equals 0.08 log plus 14 equals, yeah, I think the textbook is wrong. Did I add an extra 0? I probably added an extra 0. Yes, I did. Look at me go. Yep, that's what I did. Okay, so yeah, the textbook's wrong. Isn't it good that I did it from scratch? Okay, so that is basically how it goes. You could do it with regular moles instead of millimoles. It would work out the same. It's just your numbers, instead of being lovely numbers like 1, 9, and 8, would be 0.001, 0.009, 0.008. But if you like it better, feel free. Just remember, if you get millimoles, you need to divide by milliliters so that the millis cancel out. Is good? Okay, and that's all I'm going to teach you today, because the other class has to get caught up on this on their own time. And I don't know when they're going to do it because they're studying for their quiz tonight. And then they got grad tomorrow, so I don't know what's going to happen. Anyway, good times. Yeah, so for you guys can just study for your quiz. Okay, tomorrow. If you are done your quiz, you can work ahead on, we were actually going to, how many of you actually did, where is it? How many of you actually did pages 45 and 46? 45, 46, 47. Did you actually do pages 45, 46, 47 over the weekend?
No.
No. Oh, well, why don't you do that now?
They'll switch the other time. We'll think about video then.
Pages 45 to 47. If you've already done that, you can try the hydrolysis review on pages 48, 49. Okay, so Chem 12, I'm going to get rid of this because this is Chem 11. Of course. And look what I told Chem 11 about their quiz. It's going to be long and arduous because they've got their big mole conversion quiz tomorrow.
Oh, yeah.
Density, volume, gas, molarity, everything.
Oh,
Have you done up to page 44?
oh,
Yeah, everybody. Yeah,
oh, yeah.
everyone did 43. Did you do the questions on page 44? Nope. Okay, why don't you do page 44? 45, 46, 47. But you can also just study for your quiz, okay? Hi. Super fun. Yeah. Okay.
So like, am I able to do it tomorrow?
Yeah.
Okay.
Yeah. Yeah. Yeah.
Okay, thank you.
Hi.
How can you tell this weak acid is weaker than the H ion?
Ah, okay.
Just because the color is different.
You can tell because it produces a different color than HCl. It produces the same color than NaOH. And that means that it's a weaker acid
Oh, just
because NaOH is a weaker acid since it's a base.
just because the color is
Yeah.
yellow and it's
Yeah.
the same color as
Yeah.
like strong base.
Yeah.
Oh, okay.
Yeah.
Got it.